A substance is heated at a constant rate and its temperature is taken every minute. During the heating, the substance undergoes one change of state. So you can see here, this is a cooling curve, and what's happening is as this substance is being heated, it's increasing in temperature, and then suddenly it stops. And the reason it stops is because now the energy isn't being used to make the particles move faster, but rather break the intermolecular forces that are holding them together, to break the bonds that hold them together. And during this time, there's no further temperature increase. Remember, temperature is just the average amount of kinetic energy in the particles, and so there's not moving anymore. The bonds are breaking. Then they are moving, but they're not moving any faster. And then once they're broken, then the temperature can rise again. So whenever you see this leveling off, this plateau on a cooling curve, a change of state is happening. Here we're going from solid to liquid. So explain the shape of the graph in terms of the changes in the movement. So make sure you understand what you have to do here. Movement and arrangement of particles as a substance is heated. You have to explain the shape of the graph. So you have to tell me what's happening on the graph and then why it's happening relating to movement and arrangement. This is probably the longest 4-mark answer I've ever seen in a exam paper. So remember, this is solid, liquid, gas, and as you heat, remember what happens. So in solid, particles vibrate in a fixed position. Once these bonds break, then in a liquid, the particles can slide over each other, and then once you break the bonds holding the liquid particles together, then they can move freely. So here's what we do. Between A and B, the graph rises as particles in solid in a fixed position vibrate more. So this is describing, remember, the movement and arrangement of the particles and relating it to the graph. So that get you 1 mark. This bit, we're looking like this. So the graph rises as particles in a solid are in a fixed position and vibrate more. Next, and this is due to the temperature increasing, because we can see the temperature is rising. We're linking it to the graph. Between B and C, the graph is flat as particles in the solid use energy to break the intermolecular bonds forming the liquid. So these particles are breaking and we're forming the liquid. So that's why it's flat there. And then C and D, the graph rises as temperature increases as particles in a liquid slide over each other. So now, as I said, we're describing, once again, we're linking it back to the movement and arrangement of particles. This is actually going back to year 7 work, really. We're just describing the motion of these particles, slide over each other, fixed position, and we're just linking it to that graph. So it's actually quite an easy question, but quite a loaded one. You have to relate it to the graph at every point.